Okay, for the last video in this section, we are going to look at applying the different properties to a word problem here. So here's our problem. We've got a sound with intensity I in watts per square meter. The loudness L of I of the sound is given by the function L of I equals 10 log of I over I sub 0. I sub 0 right here is just the intensity of a barely audible sound. Okay, so what this is saying is the loudness of a sound is just equal to 10 times the log of the ratio of the sound's intensity over the intensity of a barely audible sound. Okay, so again, we've got our function here, L, is telling us how loud something is, the sound, given I. So I is its intensity, okay? So an artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. By how much decibels does the loudness increase? Okay, so we don't know what the initial sound was. We don't know the exact amount. That's fine. We don't need to. We have enough information here. So we have our formula here, and we know that the volume was turned up so that the intensity, which is I, doubled. So let's look at what we have right now. So first, we're going to say that I is going to be the original intensity. Okay, again, doesn't matter what it is, we just know it doubled. So if we let I be the original intensity, then 2 times I is going to be the doubled intensity. So that's what the intensity originally was, and then the intensity after the volume was turned up. Now let's go ahead and plug these into our equation. So we want to know by how many decibels does the loudness increase. Well, the increase is just the change in the loudness. So it's going to be the loudness with the doubled intensity minus the loudness of the initial intensity. Okay, so this is going to be our expression right here. We're going to find the loudness of 2I minus the loudness of I, where I is our original intensity and 2I is the doubled. So let's look at our equation up here. So we know that L of 2I is just 10 times the log of 2I over I initial. And your initial intensity is just, or your initial sound is just 10 log of I over I initial. Okay, all we've done, again, don't get confused by this, all we've done is we've replaced L of I and L of 2I with their function values. Okay, so again, remember I initial is a value that's just a very low audible sound. I is whatever your initial intensity was. Now, look what we can do. We can actually take some of these numbers here, and using our properties, we can rewrite this. So first thing, let's go ahead and get rid of this 10. Okay, because we're multiplying both numbers by 10. So let's just go ahead and get that out. So our loudness is just 10 times the difference of the log of 2I over I initial minus the log of I over I initial. Now, let's use one of our properties. You'll notice right here that the log of 2 times I over I0, we can break this up using our product property. We can actually split this up into 2 different logs. When we do that, we're going to split up, and this is just 2 times I over I0. So when we split that up, we get 10 times, we've got the log of 2, so we took this 2 out using the property, plus log I over I initial, and then minus log I over I initial. The nice thing right here is that these 2 right here have canceled out. These 2, log I over I initial minus log I over I initial, will cancel. And now we're just left with 10 times the log of 2. Now again, we were able to get this because this 2 right here is what factored out. Okay, this is the log of 2 times I over I0. So we just used our product property to split that up. So now, when we go ahead and simplify this, we just get 10 log 2. Now, if you hit this on your calculator, if you hit log 2 and times it by 10, it's equal to roughly 3 decibels. So that's how many decibels the sound or the loudness actually increased by doubling the intensity. So you see the relationship here. The intensity doubles, the sound goes up by 3 decibels. Now, using this same formula, so you're going to want to write this down in your notes, be able to come back it. So you're going to use the same formula. I want you to answer this question right here. So if you're using the same function, but this time the artist turns up the volume so that it's quadrupled, how many decibels does the loudness increase? Okay, so your problem, same problem here. So this is your formula that you're using, but I want to know how much the loudness increases when the intensity quadruples.